In number 11, we have yet another function that we're going to be taking the inverse of. So again, I'm going to swap my g of x for an x, and this is going to be equal to 2 divided by, this is normally g of x, but now it's g inverse of x, because I've swapped my x and my y value, then plus 1. The first thing that I'm going to do is subtract 1 on both sides. I'm going to get x minus 1 is equal to 2 over g inverse of x. And unfortunately, the g inverse of x that I'm trying to solve for is on the bottom. I need it to be on the top, so I need to flip or switch the right side, take the reciprocal. If I take the reciprocal of the right side, I have to take the reciprocal of the left side as well. So we're going to switch here. This is technically over 1, so we're going to switch here as well. Reciprocal of both sides results with a 1 over an x minus 1. And that's going to be equal to g inverse of x divided by 2. And finally, we'll multiply both sides by 2, and we get 2 over x minus 1 is equal to g inverse of x. So we have a function, and we need to make tables for both of these to see what's going on here. So let's do x, and it doesn't really matter. Both of these are kind of the same level of difficulty. Let's plug in 0. I like plugging in 0 first. Oh, look, you can't do that because it'll be 2 divided by 0. You can't ever divide by 0, so no, you can't do that. What happens if I plug in 1? If I plug in 1, it's going to be 2 divided by 1, which is 2, plus 1 is 3. And if I plug in a number like, I don't know, let's do 2, I guess. If I plug in 2, 2 over 2 is 1. 1 plus 1 is 2, so I get 2. If I plug in any other bigger numbers, it's going to be just a fraction, so let's not worry about that. Let's try negative. So what happens there? So negative 1, it's going to be 2 over negative 1, which is negative 2, plus 1 is negative 1. And when I plug in negative 2, it's going to be 2 over negative 2, which is negative 1, plus 1 is 0. Let's go ahead and graph what we have so far. Maybe that'll be enough. So when I go to 1, 3, 2, 2, negative 1, negative 1, and negative 2, 0. It's kind of hard to see what's going on, but I know that as I get closer and closer to 0, I'm not allowed to do that, which means that's called an asymptote. In this case, we have a vertical asymptote. So this line right here is kind of hard to see. Maybe if I just maybe use green, I can make it easier to see. This line right here, you're not allowed to touch. We're supposed to get closer and closer to the line without touching. So the way that we do that is we get closer and closer and closer to that line without touching. And then we have what's called a horizontal asymptote at 1. How do I know that? Because I know it's rational functions. Normally they're at 0, but I've shifted it up 1. So I know that there's also this line here that we get closer and closer and closer to, getting closer and closer and closer to. If you don't know that, just keep plugging in values. Like if I plug in really, really gigantic, like, watch this. If I plug in like a really, really big number here, then essentially what's happening here is 2 divided by some really, really big number, like 2 divided by something that's basically 0. 0 plus 1 is essentially a height of 1. You're never going to get underneath the height of 1 plugging in positive values, and you're never going to get up to the height of 1 plugging in giant negative values, which means this value gets closer and closer and closer to 1. And this value also gets closer and closer and closer to 1. And there's also this vertical asymptote that it gets closer and closer to in this direction. So there's the original graph. And again, now I just need to switch that, right? I need to say, okay, if I have x and g inverse of x, I switch those two around. So there's nothing at 0. And then I have 3, 1, 2, 2, negative 1, negative 1, and 0, 2. Interesting. And this, by the way, back here is like essentially 1. So I can say that 1 essentially goes to some ridiculously big number. There's too many zeros there. So let's plug in 3, 1. 3, 1 is this value right here. 2, 2. And negative 1, negative 1, which is right there. And 0, 2. So 0, 2 is right there. All right, interesting. I think I did all that correct. If I'm reflecting over the line y equals x, that means I have this straight line going through the function. I think something is wrong here. It feels off to me. What feels off? Switching the x and y coordinates. Did I graph something wrong? Let me see. 3, 1. Yeah, okay. 2, 2 is not graphed correctly. I don't know what I'm doing there. 2, 2 should have been the exact same point up here. There we go. So essentially what we have now is a function that looks... It's hard for me to see it. Okay, if I look at this function, this helps me on what's going on. We're not allowed to plug in what value now. We cannot plug in 1. Watch what happens when I plug in 1. If I plug in 1 right here, 1 minus 1 is 0, and I'm divided by 0. That means when I plug in 1, it jumps to infinity. Essentially what I should have said here, which is even better, is no, nothing will happen here. What's better to say here is you're not allowed to get 1. So to do that, that essentially means that we have a new vertical asymptote at 1 in this case. So I'm going to do a different green color. This is the new vertical asymptote. And using blue, we're going to say we're going to get closer and closer to that line. We'll come down here to 0 in this case. Why 0? Because this function hasn't been moved up or down. Whenever we have like a plus 1 that's going to shift it up or down, there's no plus 1 off the side. And that means over on this side, what do we have happening over here? I feel like I've graphed this one wrong as well. -1, -1 is not this point right here, but this point right here. -1, -1 is this point right here, and 0, 2, which means we have, what's going on? I'm trying to figure out where my, this is not making sense to me. This point, -1, -1 is u, 0, 2. Oh, I didn't see that negative there. That's what's messing me up. 0, negative. Okay, now that makes sense. 0, -2 is that point right there. There we go. Then that means I'm getting a line that looks like that. So this one was confusing because both those lines were almost on top of each other. All right, number 12. Let's try this one. So we're going to say x now is equal to -8 plus 7 times g, times g inverse of x. And it's all going to be divided by 2. Let's multiply both sides by 2 to get 2x is equal to -8 plus 7g inverse of x. And then let's move the 8 to the other side, add an 8, so I get 2x plus 8 now. It's equal to 7g inverse of x. And then divide everything by 7. So dividing everything by 7 gives us 2x plus 8 all over 7. It's going to be equal to g inverse of x. All right, both those functions are pretty straightforward. Let's try to pick values that are nice. So let's do the g first. So for x values for g of x, I think 0 is always a good place to start. When I plug in 0 up here, it's going to be 7 times 0, which is nothing. 1 divided by 2 is -4. If I plug in 1, is that going to be a nice number? Maybe. I don't know. Let's try it. When I plug in 1, 7 times 1 is 7. 7 minus 8 is -1, and -1 divided by 2 is -1/2, so I'll say -1/5. When I plug in 2, let's see what happens. When I plug in 2, it's going to be 2 times 7, which is 14. 14 minus 8 is 6, and 6 divided by 2 is 3. Turned out to be a nice number. Let's go the other direction. Let's try maybe like a -1, right? If I do a -1, then let's see what happens. -1 is a -7. -7 minus 8 is a -15. -15 divided by 2 is -7.5. Let's graph this and see where we're at. I think that might be enough. 0, -4. 1, -1/2 is right there. 2, 3 is right there. And -1, -7.5 is off the graph. Okay. But the cool thing about this question is it's a line. This is an x to the power of 1. Whenever you have an x to the power of 1 on the top, then it's just going to be a line. So this one I can just connect with a straight line. So there we go. There. It's the right slope, and I'll move it down into the correct spot. There we go. Okay, so there's our line. And we just have to graph the inverse function out here. So this is going to be x and the inverse of x. And we just have to swap the x and y values. So it's going to be negative 4, then 0, negative 0.5, then 1, 3, then 2, negative 7.5. Oh, that one did it. All right, so let's graph these. Negative 4, 0, negative 0.5, then 1, and 3, 2. Okay, make a line that goes through those. That's the correct slope, and I'll move it in the right spot. That is in the right spot. Okay, and again, this should be a reflection over the equation y equals x, and it does look like it's a reflection. Did we check the reflection over there? It does look like a reflection. A general rule of thumb is when you draw these black lines, there should be some sort of intersection usually happening on those graphs. Usually intersection happens. Cool. All right, that concludes our homework for, what was this? Homework 9-3 for Algebra 2. Thanks for watching.